welcome home.
Hi, I'm Orduna from the lead developer of labs-Pablo in the University of Spain. I'm here to tell you something very simple, which is that education is changing. Okay, that's something that, well, you all know, it's pretty obvious, I know it, Vicky knows it very well. But I'm not talking about methodologies or techniques or wrapping or this kind of stuff. I'm talking about the fact that knowledge can nowadays be standardized, it can be digitalized, it can be stored in CACA devices, as Jose said yesterday, and it can be shared. Indeed, there are e-learning initiatives, or there are global initiatives like this, that they are sharing knowledge, they are having massively thousands of students all around the world. And these students can see the videos and they can learn from them, they can even use simulators. And this is something which is growing. Stanford president recently in IEEE Spectrum last month was talking about that online education is something that will be transformative, it's going to change the world, it's going to change the way we think about education. Okay? So the thing is that when you're learning something, you have to practice with it, okay? So if you're learning how to program in Java, you actually need to program in Java, you have to take the compiler, you have to download it, and you have to actually code. You have to practice everything. If you're learning how to ride a bike, you can see a lot of videos of people riding bikes, a lot of advices, a lot of wikis and so on, but you actually need a bike. The problem is that in STEAM fields, STEAM stands for science, technology, engineering, and math, those bikes are actually laboratories, are sometimes, well, very often expensive laboratories that the university has to buy. And the university sometimes has to make some kind of trade-off between the price of those laboratories and how many students will actually use them. But ideally, we should have laboratories for every single course we are studying. So the challenge is, how can we digitalize these laboratories so as to make that many students can use them through the internet? Well, this field is called remote laboratories, and it has had very different names during this time. And first reported remote laboratory was in Oregon State University in 1993, but remote laboratories have changed a lot since then. In the last 30 years, now they are more professional. So the idea of a remote laboratory is basically what we are seeing in this video. The student is sending one file, and it's sending it to a device. This device is a CPLD. It's kind of, well, some kind of device. So the student is learning how to program in a programming language called the VHDL. He tests it with a simulator, and he finally sends it to a real device to test that it's really working. So this device right here, he will be able to check the inputs and outputs of the, he will be able to change the inputs so as to test that what he was thinking that it will work and what he was seeing in a simulator, it's actually working in real time in a device. In this case, if you press that button, then 1 because it's a binary decoder. This is a pretty simple remote laboratory, but there are more complex ones, such as this one, which is called Visir. It's developed by the Beckings Institute of Technology in Sweden. And the spec is price is like around 30,000 euro. It's being deployed in 6 countries in Europe. It has a multimeter, phone generator, a oscilloscope, a DC power, and it has a breadboard. So students basically take resistors and put them in the breadboard, and they can test as if they were physically there, putting those resistors in the breadboard. And finally, you say, how much is this? Well, 10 plus 1 is 11, pretty obvious. But the thing is that this, that might seem a simulator, it's actually a real hardware, it's a real equipment located in this one in Desa, that has a switching matrix that it creates, it builds that device, that circuit. And it takes a measurement very quickly and takes the response to the student. So many students can be at the same time using it. So for instance, in this class we may have it supports up to 60 students, so even all this part of the class will be using it online right now. More than that, they will be good. And so digitalizing laboratories is something which is possible within learning in this, and but it still has some challenges. If we want to increase the number of remote laboratories, we need to make development easier. This is something quite complex. It depends. I mean, it doesn't have anything to do 6 feet robots and the experiment we saw before. But for electronics devices, we can also, actually have all these this kind of box with a camera and all the inputs and outputs already controlled. And you can put here different types of devices like CPLDs, FPGAs, microchip microcontrollers. But the focus has always been more on the software side. There have been different architectures built in different universities. MIT has the ILAB system. In Australia, the Luxury Sahara Initiative in University of Technology in Sydney and other 4 universities in Australia. And in those two, we have this architecture. All these architectures, they mainly have one common thing, which is that you have some middle servers, which might not be in the middle, but they provide some common features such as authentication, authorization, scaling, and all these things. So you don't have to develop them for each remote laboratory. In the case of labs-Pablo, we support the development of mobile devices so as to enable mobile learning. When I say mobile, I mean Google Mobile, and Kindles, and so on. And administration tools to check the usage of users and so on. So the second challenge, because that's only for making your remote laboratory available for your students, but the second challenge will be making sharing laboratories possible. In order to do this, there are 2 federations. One is the MIT labs. They have been really successful in the last 5 years. They have in the 5 continents, MIT labs Europe is the consortium where we are, because our students are actually using equipment of MIT since 4 years ago. And labs-Pablo has been deployed also in different universities, like UNED, which is the second largest university in Europe. It's a distance university in Spain, and the secondary schools. And the federation is not that you say to the other university, hey, sign up all these students and they will start using it. It's more that the secondary school says, I want to use, a student says, I want to use a robot. And then the school says to the university, okay, we have a contract, so I want to use one of the robots we have in the contract, and the student finally is using the remote robot, which is being worked, which is allocated in the university. The interest on this field is increasing. Actually, the European Union will invest 60 million euro in technology and learning initiatives, and one of the outcomes is exactly supporting European-wide federation and use of remote laboratories and people experimentations for learning and teaching purposes. The main project, the only big project that has been approved will start in September. And federating remote laboratories is something cool. I have a robot and I can share it with you, and that's something awesome. But we are here in Singularity University. It should be something more ambitious. I mean, we should ask something like, how can we achieve that many people worldwide can use remote laboratories? How can we change the world towards having remote laboratories in all the courses we are studying? How can we create better engineers, better students worldwide? Shouldn't we be more ambitious? So what we think is that we have to make it possible to make the third and last challenge, to make a market of remote laboratories possible. Okay, at this point we are talking only from the technical perspective. No company is now working on selling access to remote laboratories. Actually, we are still researching on what will be the proper way for the payments. But from a technical perspective, 2 main things should be required. First one would be, we have a fish tank, which is cool, because it's a fish tank with fishes, right? And you can actually turn on and off the light. You can feed the fish, and this kind of thing. And which is even better, a fish tank is that you can control a submarine. Okay, that's something that we always wanted to do, and we achieved it. So the thing is that you have this fish tank with an embedded device which is running it, and you want to place it somewhere else, like in a secondary school or wherever. How can we achieve that? The university will share it with the other university, at this university with another place, and this can be located somewhere else, like in a secondary school or wherever. For instance, another example, if we have, as we have planned, a farm school next to Bilbao, which has an incubator with several eggs, we don't want to have that experiment in Deusto because we don't who want to work with the final chickens. So we have that in our farm school, and that has an embedded system that manages all the laboratory, and we want to share it with the University of Deusto, so the University of Deusto can resell those accesses to the university in Austria, and that university with a secondary school. So finally, students of a secondary school in Austria who don't speak Spanish will be able to be using a farm school in Spain who don't speak German. Okay, so this kind of transitive federation is what we have achieved last year. And the second thing is that if you're going to create a market, you need to scale well. So, as we said before, you remember the electronics experiment, the VCR system. It's supported up to 60 students. The thing is that we have 6 copies in Europe, in different countries. And if we put all them together, what we are doing now is achieving that we can have up to 360 concurrent students using it. Concurrent students does not mean enroll as students. It means just that they are actually using it. So, for instance, we are working in classes of 100 students, and the queue never is over 15 students. So, I mean, having 360 students will support up to, more like 5,000 students, something like that. Actually, since in this experiment you can change the resistors and so on, it will be also interesting to have different kind of experiments. So it just depends on what those universities want. At this point, what we have achieved is that there is the 3 ones in the bottom, like UNED and Deusto and ISAC are working there to share that with 180 students. So if you need more, for example, at least I have 2 printed copies there, and this book is online for free. It doesn't talk about Deusto, it talks about the other 22 institutions who have collaborated here, including MIT, LabShare, UTS, and this university, so you have all that there. And the team we are working on, the leader has also been Javier Garcia Sevilla. And so all what I wanted to say is, in this talk, was pretty much that there are many opportunities in education that might not be so clear from the beginning. There is a lot of work being held in this field, and we are working all together in different universities. So there is a consortium called Global Online over there, consortium going on this field. And that's pretty much what I want to say.
Education! Remember how his name is pronounced? Orduna, like España, like piña colada. I like that. Okay, so we will have the questions and answers here at the end.